Hey there! In this video we are going to look at how the concept of logarithms can be extended beyond base 10 to any base, and how you can determine and estimate logarithms in any base, as well as what the logBASE or equivalent key that's on some calculators does. I'm going to assume that you are familiar with base 10 logarithms, either from my previous video to this one or from somewhere else, and that you have an understanding of what the logarithm key and the anti-logarithm key for base 10 or common logarithms do. And now what we're going to do is we're going to extend that concept, everything we know about base 10 logarithms, to logarithms in any base, base 2 or 5 or whatever. And all of the concepts are exactly the same. So the thing maybe to realize here at the start is you're not going to have a specific key for each of these different bases. You're not going to have a 2 to the x key like that. You'll have a key that does exponents and powers, but not a specific 2 to the x key. But if you did, it would be called an antilog key, just the same as this one is up here, except it would need to be called the antilog base 2 key. Because when you work in some other base other than base 10, it's important to say what base you're using, because base 10 is what we commonly use, so we don't need to say that. We can just call it the antilog key. And it would, if you had that key, pretty sure you'd have the corresponding logarithm key, and it would be called the log base 2 key. And it would maybe look something like that. The way you write logarithms in another base is with a little subscript after the word logarithm to indicate what base it is. So that you would say log base 2 of whatever's in that box there. And these two things are going to operate exactly the same way as you've seen for base 10 logarithms. You could have other things as well, right? You might have base 5 logarithms, and if you had keys for them in your calculator, they would look like that. You might have base 11 logarithms or whatever. In general, we're often going to call them base A logarithms, A just standing for any base. And that's what those two functions are going to look like. Now, you may well have a key on your calculator for that. It seems like more and more scientific calculators are including that on there, but it's okay if you don't have that function on your calculator, because there's a workaround using base 10 logarithms, which you're going to learn later on when you learn about what's called the change of base rule, which I have a video on that you can have a look at now or later, whichever works for you. So instead of using a calculator, we're actually going to use a spreadsheet so we can make some lists of logarithms in various bases and look for some patterns. All right, so we have a spreadsheet set up here with columns for, this is going to be my column for my numbers, and then each of these other columns is going to be where we're going to get the program to calculate the logarithm of these numbers in the first column in various bases. I just started with, we're going to do common logarithms base 10, and then base 2, base 5, and base 11. So to start with numbers here, I'm just going to start with 1, 2, 3, and so on. We'll extend that in a minute here. But on a spreadsheet program, if you want to get it to calculate something, you put equals, and if it's a function you're looking for, you start typing the function. So logarithm, on this spreadsheet program, you can get it to calculate the logarithm of a number, and you can optionally put in the base. That's what those square brackets mean there. So if I put in just the number, so I want it to calculate the logarithm of the thing in the first column there, and close the brackets, it's going to give me the logarithm in base 10, common logarithm. So I can continue that down. It's going to give me the logarithm of those other two numbers, and then we can just carry this down here. Like that. All right, and you notice when you get down to 10, 10 is 1, because that's what the logarithm of 10 is. 10 is 10 to the power of 1, so its logarithm is 1. All of these numbers in between, those decimal numbers, because they are not nice integer powers of 10. Base 2 here, so if we want to calculate this now, we're going to go equals, we're going to start typing log again, but as you saw, I can put in that I want to calculate the logarithm of that, but then I can put comma, and I can say what base it is, and I'm going to put 2 here, because that's the base I want. Now, the logarithm of 1 is 0 in base 2 as well, because just like for common logarithms, what you're asking yourself is, what power of 10 is this number? And it's the 0 power of 10. 10 to the 0 is 1, so the logarithm of base 10 of 1 is 0. It's the same thing here. When you're asking what's the logarithm base 2 of something, you're saying what power of 2 is this number? Well, 2 to the 0 is 1, so it's also 0. But when I continue it down here, you're going to see that those numbers are different. All right, and you notice there's actually several numbers that are integers, whole numbers there. And they happen to be for 2 and 4 and 8. And the reason for that is because those are nice whole number integer powers of 2, right? Here you're saying what power of 10 is the number we're looking at. Here you're saying what power of 2 is the number we're looking at. So when you get to 2, what power of 2 is 2? Well, it's 2 to the 1. What power of 2 is 4? 4 is 2 squared, 2 to the 2. So its logarithm in base 2 is 2. And 8 is 2 to the 3. So its logarithm in base 2 is 3. You can continue that down and you see what you'd expect. Think about when we'd get to the next whole number power there. You're going to find that it's at 16 because 16 is 2 to the 4th. So that's what you get there. If we continue this further, you can predict. Not sure how far you know your powers of 2. I'm going to say about there somewhere. 32. 32 is 2 to the 5, and so on. All of those numbers in between, it still means the same thing. It's just all of these numbers, 17, 18, 19, all of those are not nice integer whole number powers of 2, so their logarithms aren't those nice numbers. If we follow along here on this and do logarithms in base 5, so we're going to still do, we want the logarithm of that number in the first column, but now we're going to do base 5, and you're going to find, I don't know if you want to predict what this one is, but this is going to be 0 as well, because 10 to the 0 is 1, 2 to the 0 is 1, 5 to the 0 is 1. The logarithm of 1 in any base is 0, because that's what power of whatever base it is. But if I continue this down here now, you might want to think about where the first time I'm going to get a whole number, a nice logarithm there. Well, hopefully you predicted it. It's at 5, because if you say what's the logarithm in base 5 of that, it's 1, because that's 5 to the 1. If we continue this on down here now, we'll go down a little bit further. And if you see there, well, I went a bit too far, but 25 is the next one. It's a 2, because 25 is 5 squared, and so on. If we wanted to continue this down to get the next one here where it's a 3, you'd have to go pretty far, because you'd have to go all the way to 125, because that's where you're going to get to 5 to the 3rd power. I won't do that right now, because we can look at this last one. Just because we had it on the other page, we'll do this one as well. This one is log of this number, but now we're doing base 11, and you get the idea by now, hopefully. That's going to be a 0, but if we continue this down, you're going to find that there for 11 is the first time you get to a 1, and if we continue this down, we're going to have to go quite a bit here. So actually, maybe I will go down here, because we're going to have to go pretty far here, and we're going to have to continue all of this down there. While I'm at it, I might stop somewhere here, because you're going to find that for 64, this was the log base 2 column. 64 is 2 to the 6, so its logarithm is there. If we continue this along here now, we're going to have to go quite a ways here to about there. I think I went a bit too far. But you're going to find a few things there. 128 happens to be 2 to the 7th. So that's its logarithm in base 2 is 7. 125, this was the log base 5 column. Log base 5 of 125 is 3. And this one was log base 11, because 121 is 11 squared, so its logarithm is 2. All of those are just exponents. Now, before calculators, this is what you would have had to have, is big printed out tables like this of logarithms of various numbers. Let's go back and summarize this idea. So for base A logarithms, any base, just as for common base 10 logarithms, the logarithm of a number is the power of the base of A that the number is equivalent to. Or in other words, the logarithm of a number, I should have said here, in base A, is the exponent that you need in order to express that number as a power of A, of the base. All right, and an example here that we are hopefully pretty familiar with, the logarithm base 2, the way you say that, log base 2 of 8 is equal to 3 because 8 equals 2 to the third. When you're asking what's the logarithm of this number in this base, you're thinking, this is you thinking, you're thinking 8 is 2 to the what? What number do I need there? What exponent do I need? So if you're thinking of that exponent, that's what it is. That's what a logarithm is. Now let's look at doing some of these mentally, just using this concept. All right, so each of these we're going to just use the concept of thinking about what a logarithm is. So this one says, what's the log base 2 of 32? And again, what you need to think there is, I'll make you a little happier this time. You didn't look very happy last time when you were thinking. But maybe as you're getting better with logarithms, there's a slight smile there. So if you're saying, what's the log base 2 of 32? What you need to think about is 2 to the power of what is 32? How do I express 32 as a power of 2? And you might happen to know what it is, or even if you don't, just start multiplying 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 5 of them, right? It takes 5 2's, so log base 2 of 32 is 5, and the reason is because 32 is 2 to the 5th. That exponent is the logarithm, all right? The second one here, log base 3 of 81. Again, what you're thinking is, you're thinking 81 is 3 to the power of what? What exponent do I need there to get 81? You might happen to know. You can work with what you know. 81 is 9 times 9, and each of the 9's is 3 times 3, so it's going to take 4 of them to make that 81, so that's a 4. And again, the reason is because 81 is 3 to the 4th power. The next one here we have to think about maybe a little bit, because this fraction, this reciprocal, that's the reciprocal of 64. Maybe it's easier to think about, let's think about if this 1 wasn't there. Log base 4 of 64, well, you got to try and get 64 from 4's, so think about how many you need. 4 times 4 is 16, times another one is 64. 4 to the third is 64. Now the problem is we have 1 over 64. If 64 is 4 to the third, 1 over 64 is 4 to the negative 3. All right, that's an exponent law I hope you've seen before. A negative exponent means the reciprocal of the same thing with a positive exponent. All right, so 1 over 64th is 4 to the negative 3, so the logarithm base 4 of 1 over 64 is negative 3. This next one is probably so easy that it actually ends up seeming hard, or you have to stop and think about it there. Log base 7 of 7, so what you're thinking is 7 is 7 to the power of what? Well, 7 is 7 to the 1, so this is 1. The logarithm of that number is just a 1 there because it's just the first power of 7. The ones down below here, this one's a little bit trickier because the base is a fraction there, but you're still thinking exactly the same thing. If you say log base 1/5 of 25, what you need to be thinking about is 1/5 to the power of what is going to give me this 25. Well, you probably know that 25 is 5 squared. So if this was log base 5 of 25, it would be 2, right? Because 5 squared is 25. And if we want to make this instead what power of 1/5, well, we actually need to raise it to negative 2 because this number to the positive exponent is the same as the reciprocal to a negative exponent there. So that is actually going to be equal to negative 2. Log base 3 of 3 to the 5th. This one actually, it looks a little more complicated, but it's actually set up so that you can just read the number right off of it. Because if we're saying the log base 3 of this thing right here, we're saying, how do you write this thing as a power of 3? Well, it already is a power of 3. It's 3 to the 5th. So if you're saying, what's the log base 3 of 3 to the 5th? It's just 5. Next one here, log base 6 of square root of 6. This is going to require that we think about how do we write that as a power of 6. And you may know, I hope you know, that the square root of 6 is the same as saying 6 to the 1/2. So the way you can write that as a power of 6 is 6 to the 1/2. So its logarithm in base 6 is the exponent, which is the half. So this is 1/2. And then that very last one there, log base 8 of 2. Now you might say, hey, I know that one. We saw it before. It's 3. It's actually not 3 because it doesn't say log base 2 of 8. It says log base 8 of 2. So what you're thinking is, what power of 8 is this number? So 8 to the power of what equals 2? Now you probably know that 2 to the power of 3 is 8, but that's not what we're looking at here. We're wondering 8 to the power of what is 2? Well, 2 is the cube root of 8. So I would need to say here that this is the cube root of 8 is 2. And instead of the cube root, we can write that as 8 to the power of 1/3 equals 2. Just like square root, you don't usually write the 2 in here, but it's to the power of 1/2. The cube root is to the power of 1/3. If we were looking at the fourth root of something, it would be that to the power of 1/4, and so on. So if we know that 8 to the 1/3 is 2, then log base 8 of 2 is 1/3. All right? Let's look at one more thing here. Now we're going to do some estimating of logarithms, and we're going to do it using the ideas that we've already seen here about what we know about logarithms in different bases. So we'll start with this one, log base 2 of 19. Log base 2 of 19, well, 19 is not a nice power of 2, but we can use powers of 2 that we know on either side to help us estimate. So if we think about what number is smaller than this, power of 2 we know that's smaller than that. The next power of 2 down from 19 is 16, right? So we can think about this as log base 2 of 16, and we know log base 2 of 16, if you remember those tables, those numbers just progressively get bigger and bigger. Log base 2 of 16 has got to be smaller, so we're going to write that this is less than here. And the next power of 2 up from this is 32, so log base 2 of 32 is going to be one that we can work out here, and it's got to be less than that. So log base 2 of 16, 16 is 2 to the 4th, so its logarithm in base 2 is 4. 32 is 2 to the 5th, so its logarithm in base 2 is 5. So then this value here, log base 2 of 19, has to be between those two things. And you might think, okay, well, 19 is closer to 16 than it is to 32, and that's going to maybe help you give a rough estimate. You might not be sure what to say, but for sure you know that it has to be 4 point something here, because it's greater than 4, but it's less than 5. And that's the main idea here. It's not so important what we put as our second digit here. You might say, I don't know, 4.2, 4.1, or something like that. We're going to check it with a calculator in a minute, and we'll see. Second one here, log base 5 of 60. We're going to use the same idea here. Log base 5 of 60, we're going to think, which powers of 5 do we know on either side of that to help us? So the next power of 5 down from 60 is 25. So log base 5 of 25, we know that that is 2 because 5 to the 2 is 25. And you know that this has to be below that, so the value we're looking for is greater than that. And we know the next power of 5 up from this, we saw it before in the table, is log base 5 of 125. So we're going to pin it between those two things. We know that log base 5 of 25 is 2, and we know that log base 5 of 125 is 3, since 5 to the 3rd power is 125. So then this has to be in between those two things. And so we can say the value we're looking for is between 2 and 3. And again, we can try and pin down what it is, but at the very least, we need to know it's 2 point something since it's between 2 and 3. You again can look and say, well, 60, maybe it's closer there to there. It doesn't really work in a linear kind of fashion, so you can't say, well, it's halfway, so it's going to be 2.5. This one actually, maybe you're going to guess 2.4, 2.5, something like that. We're going to check it with a calculator again in a minute. And that third one there, same idea. Log base 12 of 7. Well, this one's a bit trickier because 7 is smaller than 12. So if we think, what powers of 12 do we know? Well, we know, maybe you don't know many. 12 squared is 144. That's way too big. 12 to the 1 is the next one down. It's 12, but we're even smaller than that. So we're going to go next down. 12 to the 0. 12 to the 0 is 1. So actually, we're going to pin it between these two numbers right here, in between 1 and 0. So the two logarithms we're going to use is log base 12 of 1 and log base 12 of 12. And we know it's going to be less than this one and greater than that one. And again, the reason is because 7 is less than 12 but greater than 1. And those two we know, this is 0, this is 1. And so that value is between those two. And so we know it's got to be 0 point something. Now again, you can kind of look and say, well, 7's maybe halfway in between, and just maybe you're going to guess 0.6, 0.7, something like that. You're going to find when we go to a calculator in a second here, it's actually surprising. It's closest to 0.8. Again, it doesn't matter what we're actually estimating here, as long as we can kind of see this part of it, that what it starts with as an understanding of what these things are. Now, I mentioned we're going to check it on a calculator. We are going to do that right now. All right, so that first one we have to check, log base 2 of 19. On this calculator, it's not a button that is evident on the front. It's buried inside a menu. There's a couple ways to get to it. The quickest way on here is to go here. It's actually down at number 5 there. Log base. It says log base in the menu, but it shows up exactly how you write it on the paper. So we want log base 2 of 19. And if we check what that is, 4.2 something. So pretty close to what we had guessed, 4.2. If we do this again for the second one, log base 5 of 60, 2.5, basically what we guessed. And then the third one here, log base 12 of 7, about 0.78. As I said, it's maybe higher than you think. All right. Now again, don't worry if you don't have a calculator that does this, because as I showed you earlier, you can use a spreadsheet. You can go on online. There's going to be all kinds of logarithm calculators. Desmos, if you're familiar with Desmos graphing software, you can use that as a calculator. Just punch it into the space at the left and it'll give you the values. All right, let's do one other thing here. Now, we're going to do one last thing here with something that looks actually quite complicated, but I want you to see that it's not necessarily as complicated as you think. All right, we have something that has several pieces here. We have actually sort of 3 terms there. We have that term, we have this term, and we have this thing, this 4 on the end. Now you might think, isn't that 4 part of this? Isn't it the logarithm of that whole thing? In other words, isn't it the logarithm of all of this? It's not. If you wanted it to be the logarithm of all of that stuff, you would have had to put some brackets there like that. If it's written like that, the 4 is a separate thing, and we'll get to that after. So we're going to evaluate it kind of each term separately there. Log base 5 of 25 to the x, you're going to think about what power of 5 is this, and you can see, you can write the 25 as 5 squared, so we could write this as 5 squared to the x. We're looking at the log base 5 of that. Well, we can write it as log base 5. We can simplify this piece first. 5 squared to the x, you have a power, so you can simplify it by multiplying those exponents and just writing this as 5 to the 2x. And in fact then, log base 5 of 5 to the power of something, again, you're saying what power of 5 is it? Well, we can see it's just 2x power of 5. It's that exponent, right? The logarithm is that exponent. The second term, log base root 3 of 9 to the x minus 1. Well, log base root 3, that sounds and seems a little bit more challenging, but we're doing exactly the same thing. We're thinking, how can we write this as a power of root 3? Well, 9, I'm assuming that you recognize 9 is like 3 times 3. But each of those 3's is like root 3 times root 3. And this one over here is root 3 times root 3. So actually, 9 is 3 times 3, or it's root 3 times itself 4 times, right? Or root 3 to the 4th power. 9 is equal to root 3 to the 4th power. So how we could write that is we can say we're looking for log base root 3 of, and that part right there, that 9, we can write as root 3 to the 4th power. And then we have our x minus 1 as our exponent, and I'll just keep this plus 4 there so that we don't lose track of it, right? So that 9 we've written as root 3 to the 4th, and then we can simplify this part of it, right? You have a power again, and you can write it as root 3 to the 4x minus 4. And we have log base root 3 of that. And again, the concept is exactly the same here. If you have log base root 3 of root 3 to the something, you're saying what power of root 3 is it? Well, we can tell. It's that. That's the exponent. So we just have 4x minus 4. And then I'll keep this plus 4 here. So once you have it down to there, then it's a piece of cake to finish that, right? We have 2x plus 4x, which gives us 6x. And actually, those two things add to 0. So actually, that whole thing is actually equivalent to just 6x. So on the face of it, even if you have something that looks really complicated, don't panic and start to think that it's something very challenging, because it isn't necessarily. All right? So that is a look at logarithms in base A, any base.